Thank you, Tina, for opening this, because that's something that I want to carry forward, what you just discussed. But before I do that, first of all, I mean, it's a privilege and honor to be speaking at this conference and one of the most dynamic, talented, and perhaps vibrant developer ecosystem. So thank you, Devcon, for giving me this opportunity to speak about here. So my talk is based on one of the research work that me and my team had done earlier. And this paper received a number of citations, both from academia and industry combined. So I thought maybe this is a good opportunity to share some of the thoughts that we had around it with this community. And hopefully, whatever we have started, this community can take it forward and also take it to completion because some of the things that we have started, these are solving some of the complex challenges. And I strongly believe and very much optimistic that if this can be solved, there will be this community. So before I go further, one of the key things that I wanted to highlight is I know there are a number of discussions and topics around decentralized AI, pretty much decentralize everything. But in this specific case, I'm speaking about something slightly different. It is about Federated AI. This concept is something that started a few years back by Google, where just giving you a quick primer on this, that there are multiple organizations can train the machine learning models locally, and then they can share the models, not the data. And this is a very, very important concept, especially with the privacy and regulations, where no institution want to share their respective data, but they are at least willing to share the insights from that data set in form of a model. And in this setup, if you can see, there are multiple organizations, each trained locally, and then they share with the aggregator, which combines it. And hopefully, the belief is that a combined model is much better performing than the single ones. How do we achieve it, right? So one of the proposed solutions that we have in the paper, by the way, a lot of the details is in the paper itself. At this point, I'm just highlighting a few of the key top points and also some of the challenges. But one of the challenges with the adoption of this kind of technology is everyone would like to know what's in for me and how do I get incentivized for something that I'm actually contributing towards a global model. So the solution that we laid out is a smart contract-based contribution analysis framework for federated learning. Then we also design and develop techniques for federated contribution. By the way, this federated contribution term, to the best of our knowledge, did not exist before, so we think we actually coined this term. And then we also have enhanced security for private messaging between the contributor, if you saw the prior slide, and the aggregator using dynamic key generation. It uses traditional cryptography. And finally, leverage Ethereum to build economics of on-chain reward and penalty, just in case some of the contributors are malicious. One of the key things I wanted to highlight, and before I went to this, this talk falls right in between the intersection of blockchain and AI. So some concepts are, some of the slides you'll see it's purely machine learning, and quickly highlighting the ML part of it. An ML model at the underlying, at the pretty much foundational layer is a set of metrics with set of numbers, which you can actually, which are laid out in this format. In case of federated computation, so we have a number of metrics. If you can imagine in the diagram before, we had a number of contributors giving their respective models, and how do we come up with one single number that identifies the contribution from each of the contributors. So we use federated computation, and if you are familiar with linear algebra, it's about leveraging Frobenius normalization that takes two metrics and merges the two and comes out with one single number to give us the final number. Finally, how do we calculate it? So within the aggregation layer, after each round of aggregation, federated contribution is recorded on chain. Each of the clients receive that contribution. The client goes back and does the evaluation again of that model against its own data set and sends back the performance, the actual computation performance back to the chain. And then there's a smart contract that picks it up and does the analysis of that. The framework is fairly simple. I mean, again, all the details are in the paper. However, from a high-level perspective, there's one smart contract that manages the entire stack. There are 3 different functions, and one of the key functions in that is how do you actually set the contribution, which is right at the center of the slide. Okay, I think I just 5 minutes. Any questions? And some answers, maybe.
Any questions? It's quite a fascinating topic about documenting the contribution. Any question from the audience? Yes, we got one. Yes, I get to throw this. Wow. Amazing.
Hi. So speaking of what you've done your research on, what is still open, where would you maybe just name a few fields within Federated AI where research still has to be done? Or are we done?
Oh, yes. Actually, this is a very, very active area of research. And some of the key topics that are being researched around identifying the malicious actors, finding a way to incentivize what I just described is how do you incentivize the contributors to the global model. And also, like, there are different algorithms that are being discussed on how do you optimize the end-to-end communications. So broadly speaking, there are a number of challenges. At the same time, there are a number of opportunities which are being explored at the moment.
We have the guy in a white shirt. Yes.
Hi. Thanks for the great presentation. Can you talk about some best practices on incentive design? How to get clients to contribute checkpoints that are improvements and not going backwards on the original model?
That's a great question. In fact, one of the main challenges in identifying the right rewarding mechanism is how do you actually assess the performance of the global model, right? So one of the challenges that we ran into was each client can have a different data set. The quality of the data set could be different. The size could be different. The number of iterations could be different. And so one of the potential practice or one of the potential solutions that we identified, again, by the way, just for a disclaimer, some of the work that we did was in a permission network. And that normalizing, some sort of global normalization of attributes, the parameters, and the training algorithms could be helpful in normalizing or maybe coming up with the right metrics to combine. Otherwise, you could see very varying performances, which could be misleading. Could give you misleading results. Yeah.
We have time for one more question. Oh, actually, time's up.
All right. Thank you so much.